right, our next presenter. He is a hydrologist and meteorologist with the Columbia River Intertribal Fish Commission, joining us live from Germany. Kyle, are you with us? He is there. Running Kyle's presentation, our Vice President, Steve Pierce.
Okay, greetings from Germany. Kyle Dittmer here, reporting live near the Brandenburg Gate in Berlin. Steve, first slide here. I'm here in Germany for 2 weeks. Real quick here, I'm actually interviewing some climate scientists here at the Wuppertal Institute and other places, looking at the latest in climate change research here with the Germans. Been getting a lot of good information. I'm going to come back and present to the AMS chapter here later on in the year, so something to look forward to. But for right now, let's take a look as far as the weather. Next slide. How do we weather forecast? We know the computer model usually says what's really going to happen. Well, the next slide shows how we use the scientific method to discover that answer. And as you can see, there's really two ways of how we discover things here. I mean, there's the way normal people work, and there's weather forecasters. Okay, let's go on to the next slide here. As far as the methods here that I use a suite of many different forecast tools and indices to look at here for the next few months. I do look what's happening in the sun as far as solar forcing. This is an idea that was promoted by the late Dr. Theodor Landscheid, all the way from Germany, who developed a model that showed the relationship between solar activity as measured with sunspots and the relationship between ENSO events, El Nino and La Nina. I also take a look at ENSO as shown through the multivariable ENSO index. I also look at sea surface temperature departures. And my claim to fame is this hydroclimate approach where I use the relationship between the MEI and the historical Columbia Canal's historical runoff. And I generate a water supply forecast from that relationship. And I back engineer the weather patterns based on 20 analog years. So it's a unique way to find out the actual weather patterns. And for my analysis this year, of the 20 years, 16 of them I've chosen as La Nina years, or 80%, and 4 ENSO neutral years, or 20% of the years. Also, the 20 have included 8 as sunspot minima years, showing at or close to the minimum of sunspots. And particular analog years that I've used include 1943, 48, 50, 51, 54, 56, 65, 67, 71, 72, 74, 75, 76, 82, 84, 96, 97, 99, and 2006. So next slide here. Let's take a peek here at the sun, what's going on here. As probably has been presented earlier, the sun has been unusually quiet here during the last 2 years. The sunspot counts are starting to come up. They're still fairly low though. And so I think that's going to play a significant role in our weather here this coming wintertime, even probably more so in the last 2 years. The next slide shows the sea surface temperature departure forecast as given by NOAA as of a few days ago. And if you look at the blue color values down in the tropical Pacific, it is showing that we're going to have much colder than normal temperatures, which is very favorable for La Nina conditions. And in the previous slide, I talked about sunspots. When you're near sunspot minima, that too is very favorable for conditions of La Nina. The next slide, which shows the MEI, shows probably the sharpest drop-off here during the summertime period we've ever had. And we're clearly in La Nina territory and are expected to stay there. The next slide showing the PDO, the Pacific Detail Oscillation, which is a longer-term measurement of the ocean conditions, shows we're in negative territory, which also indicates we're going to have very favorable conditions for La Nina. And the next slide shows my stream flow forecast here. The blue line shows the average of the last 80 years, and the red line shows the forecast that I produced here for water year 2011, which we just started here on October 1st. And I'll talk more about that here in just a minute. In fact, I'll just mention right now that based upon the MEI data here, as of through September here, I'm calculating a runoff year of 129 million acre feet, or about 120% normal. And to put that perspective, that would give us runoff somewhere between what we saw in 1999 and 1996, which was a big flood year we had 14 years ago. So that's my methodology there. Okay, if you turn to the last slide here, summary here of the forecast based upon the average of all those 20 weather years, looking at the temperature forecast here. I'm looking for near normal temperatures for the most part throughout the wintertime, leaning a little bit toward the slightly warmer side by midwinter, like perhaps maybe January, but actually looking to turn really cold for February, March. So I think this is going to be a very good indicator of some cold outbreaks, perhaps maybe in February, and potentially more snowfall during midwinter. As far as the precipitation totals here, looking to be above average across the board here, above normal both November through February, with really the heaviest totals here during November and January, and back up a little bit in December, but still above normal by the time we get to February and March. I'm also expecting variability in the weather, so we'll see Pineapple Express events most likely in November, with associated flooding here on the west side of Oregon and Washington. Arctic blast, probably very likely will probably be, well, definitely can happen in January, but definitely February for sure. But what about snow events? And I've done calculations here. Based upon what I'm seeing here, I'm expecting 6 events, each one to be between 2 to 5 inches or more, with the exception of the last one, which I think will happen in March. Giving you the probabilities I'll calculate here for snow, I'm looking at 40% probability of snow in November, maybe less than a fraction, so I don't think we'll see any snow here. 80% chance in December, so I think we'll probably at least see one snow event sometime by mid to late December. January, 90% chance, so I think we'll probably see 1 or 2 events in January. February, 85%. And March, 95%. So I think we'll see like a little scoop of snow during early March, but I think we'll see 5 other significant events, my calculations between 2 to 5 inches apiece. So that would probably cause a lot of problems around the Oregon metro area. So we'll see how that all plays out here. And that's all I have, unless there's any specific questions.
Any questions for Kyle? 7,000 miles away. Yes, right here on the side. Hang on 1 second.
I'm a middle school teacher, and we were just studying sunspots yesterday, and there was 260 sunspot-free days last year, and then this year there's only been 45. So that's a significant drop that correlates with that big drop, or that big El Nino La Nina drop. So I wonder if they're correlated.
Kyle, did you get that?
I did. The sunspot counts have been low. There's no doubt about that. The problem is we don't see a real direct relationship between the SOI and the sunspots. Although I did read some new research in BAMS here about a year ago saying that the fluctuations in solar activity as measured by sunspots is actually playing a much bigger role in the stratospheric winds, much more so than we've known previously. And of course, how does that filter down to the lowest reaches of the atmosphere? That's something we're filtering out, but definitely we're starting to see more connections between solar activity and the mid-upper layers of our atmosphere. So we're still trying to figure out what all this means, but I think we're starting to see more signs of this connection between the sun and the dynamics in the slower atmosphere.
Okay, next question. Hang on, we'll get right to you here. Hold on, Kyle.
Okay.
You were mentioning that we are expecting to see a couple Pineapple Expresses. Do you think that that would be what possibly breaks the ridges of Arctic air that comes down to the Portland metro area? And if so, do you think that that could also increase our chances of freezing rain?
I think the Pineapple Express events are really more common during the October through December period. As far as the Arctic outbreaks, I don't really expect to see those until probably like midwinter, like about the middle of January onward. So I see what you're thinking, but I don't think the Pineapple Express events will have a real major influence during the Arctic outbreaks. Because those folks who were around in February of 1995, we had probably the last real major Arctic outbreak as far as during the February time period. And the season for Pineapple Express was over at least by 2 months at that point. So I don't think we're going to see any relief from a Pineapple Express as far as the Arctic outbreak. I think what happens is that we just have some more airflow coming out of the Pacific, and that, that trough and the ridge breaks down, things eventually move eastward, but that can be a very slow process sometimes.
We have 2 more questions. Gentleman over here, sir.
Yeah, you mentioned the scary word. You said 96.
Yes.
I'm wondering how you think this year is going to compare to 96.
I think it'll be more similar than that. I think the major difference between now and 96 is that we had a lot of low elevation snow during February, and of course then we had this freakish Pineapple Express event right on top of that. It could happen, but I think this year will probably play more like 1999. We'll just get tons of snow. It'll be slow runoff. It'll look scary, but I don't think it'll be anything like 96, which is really kind of like a once-in-a-50-year event. So if I had to put money on it, I probably would wager more on the 1999 year where we actually had big volume, but let out slowly during spring and summertime, just like a classical snow melt sequence.
All right, one last question. Anybody? Kyle, we appreciate it, and we can't wait to hear back from you when you get back to the States. Enjoy the rest of your time in Germany.
Oh, good night.
Thanks, Kyle.